Hi friends, this is your friend Olafem to talk. So we are number question 1244 physics, WIC 2025. Now, a bullet of mass 0.025 kilograms moves at 250 meter per second. Uh, Calculate its DeBroglie wavelength, given these constants here. So now, the aspect of the Broglie wavelength has to comes when we are talking about a uh, uh, an electron behaving like wave, right? According to the hypothesis of the Broglie wavelength, it talks that all matter, not only light, okay, exhibit both particles and then wave. That is when we are talking about wave particle duality, and it's the Brownian wavelength so find its significance in particle in the behavior of particles at atomic level and subatomic level, especially where um, quantum mechanical are crucial, are very crucial. But when it comes to classical level, the Brownian wavelength is so small that wave properties will be so negligible. So it finds its usefulness when we are talking about the behavior of particles at atomic or subatomic scale. So the Brownian wavelength, the concept of the Brownian wavelength find its application in so many technologies we have today, like quantum computing, particle accelerators. Okay, so now also before I move to the Brownian wavelength is inversely proportional uh, to the momentum of the particles, right? The momentum of the particles, which can be can be further written as h over mv. So where your h is your Planck constant, your Planck constant. So where your m is your mass, the mass of the electron, and then the velocity at which the electron moves. Okay, so now let's go and see how this thing will work. Now, the developing wavelength, which can be written as this, that is your Planck constant is 6.67 times 10 to the power minus 34. Okay, over what is the mass of the bullets talking about? So this is 0.025, 0.025. So it moves at what velocity? It moves at 250 meter per second. So 250 meters. Okay. So by the time you calculate this, multiply by this, 0.2 meters, by the time you press it, 0.025 times 250, that will give you 625. Okay. So divide this one by this, give you 1.06 7 times 10 to the power minus 35. I mean 34. Okay. So which is approximately to 1.07 times 10 to the power minus 34 meters. Okay. So this is the Brownian wavelengths at which these possessed by these particles. Right, we can see that the size is so small. Okay, so that is why we say that it's only uh, talks about the find its usefulness in we are dealing with atomic, subatomic scale. Okay, that is the particles and the behavioral particles at atomic, subatomic scale. That is where it finds its relevance rather. All right, thank you.